in environmental engineering and management. He has previously worked with some R&D projects and has presented research outputs in scientific conferences and LGUs. He has also published some international scientific journals, and he is one of our peer reviewers of the Elsevier Journal of Cleaner Production. With this said, it is my honor to present to you our first speaker for the perspective of the oil and gas industry towards energy transition. I now call on Engineer Jonathan Jared Ignacio, and without further ado, let's start with the first session. Engineer Ignacio, good day. The time is yours, I believe.
Hello, good day. Thank you for the introduction. Let's start our session for this morning. So I think I'll be the first session. So to everyone who are here, good morning. So this morning we will discuss some information related to some disciplines such as petroleum engineering, energy engineering, and also environmental engineering. I will discuss to you the perspectives of the oil and gas industry towards energy transition. And again, my name is Engineer Jonathan Jared J. Ignacio, and I am a faculty of the Department of Petroleum Engineering at Palawan State University in the Philippines. I'm also, just like what we mentioned, I'm also a chemical engineering student, PhD student rather. So next slide, please. I hope you can hear me clearly. Am I audible? Okay, so at the end of this discussion, you will be able to understand the answer to the following. Okay, I'm not saying here that you will be able to answer it directly, but at least you will be able to understand the answer to the following questions. Why must emissions be reduced? How energy transition works as a solution? Current condition of oil and gas industry regarding the net zero emissions target. These questions are really, really timely for all of us. And for petroleum engineering students, some of you or many of you are questioning the future of the oil and gas industry. In this presentation, I will explain it to you and I will give some clarity to some of the important factors and issues that our industry is facing today. So next slide, please. Okay, but before I start, I want you to get to know me so that we'll have a little bit connection before the lecture. Again, like what we mentioned earlier, I'm a PhD student in chemical engineering at the Salle University, Manila, wherein I also finished my Master of Science in Environmental Engineering program. Okay, so I'm also a petroleum engineer. I graduated at Palawan State University last 2014. Next slide, please. So I'm an associate member of the National Research Council of the Philippines in the Engineering and Industrial Research Division. The moderator earlier also mentioned that I am a journal reviewer in Elsevier Journal of Cleaner Production and Maurice Year. Next slide. I work in several research projects, including petroleum engineering projects and chemical and environmental engineering projects. So I've been working with many engineering disciplines in collaboration with different departments in our university and also in collaboration with other universities in the Philippines. So right now, I'm an instructor at the Palawan State University. And next slide, please. And I published several articles with my students in the previous years. Next slide. Next slide, please. And next slide. Okay. In the previous years, I've been working really hard. I've been dedicating myself not only as a student, but also not only as a student, as an instructor, but also as a researcher. So What I'm going to share this morning is based on what I've learned from those experiences and why it also led me to this recognitions in the past years. I will share to you my knowledge and skills on the this pertinent topic. Next slide. So right now in this world, um, we've been enjoying a lot of things. For example, transportation, our gadgets, laptop, gaming gadgets, music gadgets, and many more. We've been enjoying food. I love food. Personally, I really love going to places and trying new food. And we've been also, this event is also made possible because we have electricity. And almost in our daily lives, we use electricity. Okay, next slide. And all of this is, and we can thank all of this because of this particular microorganism, plankton. Okay, so you can see that plankton here is really, really happy about everything for acknowledging him. But we're not talking about this plankton. Next slide, please. We're talking about these planktons, these very tiny microorganisms that we cannot almost see with our naked eyes. I mean, we cannot see with the naked eyes. Throughout time, it will decompose and it will turn into a valuable product. Okay, next. Uh, okay, so next slide, please. I think Plankton is really disappointed because he's not being the one being acknowledged for this. So anyway, I think there's somebody opened her or his phone, his microphone rather. So because of this plankton, we were able to enjoy the benefits of the crude oil and with crude oil that is being processed for our consumption. For example, electricity, fuel for transportation, and many more. Next slide. Again, uh, it leads us to this. The crude oil is an important factor why we are experiencing all of this transportation, even the materials being used in the buses, in our cars, motorcycles, or whatever mode of transportation that you are using every day to come to school or work. So before we have those handles, there is mining, and mining activities also needed or necessitates the fuel to operate. Gadgets, different gadgets that we use, even for this online, for this virtual event, for us to manufacture these gadgets, we needed the fuel and some of the petroleum derivatives that are essential for as a byproduct, as a product, as a raw material rather, for the manufacturing of these gadgets. Same as in food, we use fuel to cook our food. We also use fuel in agriculture, in poultry, in livestock, and also in fisheries. That is why we're enjoying the food because of the oil and gas industry. And again, we cannot do all of these things without electricity. Then, next slide, please. So let me take you back in time. There are a lot of things that happened in time before it led us to this world that we are living in right now. Back then, next slide. Next slide, please. So back then, people are using whale oil. Go back. Okay, people are using whale oil for fuel for lighting their lamps. However, as time goes by, when the whale oiling industry or whale hunting industry become really, really attractive to many people, there was a high demand for whale oils. In return, people needed to hunt for more whales, need to kill more whales just to harvest whale oil that is being used by the people to light their lamps at night. So, um, when the population of whale in the shallow water became smaller, when it decreased, the whale migrated to the deeper part of the ocean just to escape from the humans. However, it eventually it it had a negative effect to the people who are hunting for whales. It is more difficult to sail, or it is more difficult to hunt for whales in the deeper part of the oceans because it is not more economic for them. It will not be economic and safe for the people who are hunting for whale oils. So eventually, this industry started to die. Next slide. And um, when the demand for energy led us to the discovery of alternative sources, we had coal. We discovered coal, and coal is being mined, and coal is being used to generate energy. This energy is being used to run engines. This is when the Industrial Revolution started. Next slide. Okay, so please go. Can you please go back to the other slide? Okay. Again, next slide, please. Sorry. Okay, so and then eventually, after some years, um, Edwin Eldrake discovered the first oil in the United States. Then everything, and the rest is history after that. So next slide. I want to highlight the Industrial Revolution and why is it affecting us and why it is important in our topic for today. Next slide. Right now we are in the transition to the Industrial Revolution 4.0. So we started the mechanization, steam power, weaving loom in the first Industrial Revolution. The one that I showed you earlier, wherein we use coal to generate steam for energy production, for example, to run trains, to run some other engines. And then we discovered fossil fuels that includes crude oil and natural gas. It then took a spark in the worldwide industry, which includes mechanization, modernization, and others, and digitalization. Now we are already in the second industrial revolution, rather, because the population of the world is starting to increase, then there is a higher demand of different products worldwide. It is difficult to produce this product or to manufacture some of the products, including, let's say, a knife or some garden tools or some axes or plates that are being used in our daily lives to survive. But during the Industrial Revolution 2.0, they actually tried to maximize the use of the fossil fuels to produce more goods for the benefits of the people. What I'm referring here are not only devices, are not only engines, but also food and water, clothing that are essential for human survival. With the Industrial Revolution 3.0, we started the automation industry, computers and electronics, which until now we are still experiencing today. So in the Industrial 4.0, wherein we are now already in the transition for this, or we're already getting there, we require more energy, and more technologies to adapt to this new industrial revolution. This includes cyber physical systems, Internet of Things, networks, etc. So next slide. Next slide, please. Okay. Like what I mentioned earlier, there is a significant increase in the world population worldwide annually. So this means that if the population increase, then therefore the demand for certain product or services will also increase. For example, food. If there are more people will demand for food. This means that the agricultural sector needs to improve or needs to improve their production. So if there are more people, many people are going. Many people will also need for water. So for us to get water from a certain reservoir, we need more pumps, and pumps require energy. If there are more people, many people will need clothes, and clothes, to manufacture clothes, there will be certain materials that will be required to manufacture these clothes. For example, cotton industry, which are water intensive and resource intensive and energy intensive. This means that when there are more people who will require for more clothes, there will be more need for electricity and other electricity and energy for to manufacture these goods. So these are just basic human needs that I'm referring to. We're not yet talking about the effect or the impact of the technologies and other demands of the people worldwide. So next slide, please. Okay. And then it will always go back to this. When there are more people, many people, when there are more people will require transportation. It means that there is a need for more cars or more public transportation or whatever. So if there are more people, because we are already modernizing and we're already approaching the Industrial Revolution 4.0, we need to get more technologies, we need more gadgets, we need to accentuate the production, the manufacturing of this equipment or these technologies. This also means that we also need to accentuate the mining activities because most of the raw materials being used to produce this equipment will require materials that can only be retrieved through mining. And if there is a higher demand for mining activities, then there will also be a higher demand for energy. So when there are more people, many people will require food to survive. Okay, so and now since we're already modernizing, people do not cook in their houses anymore. Many people do not cook in their houses anymore. They go to the restaurants because there is high demand for food services. So if there are high demands for food services, it means that it will require construction of restaurants, bars, cafes, etc. And it will also require it will also require the manufacturing of kitchenwares, etc., and also the fuel being used to cook those food. So if there are more people, it means there are more number of households worldwide. It means that many people will require energy. It means that many people will demand for electricity. So most of the most of the sources of electricity that we have today, although renewable energy is already emerging, um, most of this energy that we use now are coming from the fossil derived fuel. So next slide, please. So I hope that you can understand what I'm trying to say here. So so aside from the population growth, we can see that there's also a similar trend or of increase in the energy demand worldwide. So when we are yet starting, or we are just starting the first industrial revolution, you can see that in this graph from the IWRE, which was published in 2013, you can see that the energy demand is quite small. During the first industrial revolution, we mostly used coal, but after the discovery of the hydrocarbons, um, there's also some demands were also created. That is why um, we try to at least increase the uh, the natural gas and crude oil resources and other sources of energy just to supply those needs. So again, there is a similar trend to the population growth on the energy demand. So when we say that the population is increasing, we can also say that the energy demand can also increase. Next slide, please. Okay. So before I discuss this figure, um, let me tell you that let me also tell you that the population growth worldwide is not slowing down. So in the future, it is projected to still increase. So and yet now I'll discuss this. And yet we are experiencing many problems worldwide, especially that are related to the environment. Many people are living in vulnerable communities, and the effects of if the effects of environmental damages such as the CO2 emission from different sectors are also affecting them indirectly and directly. So um, so here we can see that the China has the highest. Sorry. So whenever there is a high demand for electricity or fuel or energy in general, it means that it could possibly mean that I'm not saying that it will absolutely mean, but it can possibly mean that there could be a higher CO2 or carbon dioxide emission in that particular locale. So um, so if there's a tendency that the countries that have countries that have higher population could also have higher CO2 emissions. But we can see on this graph that it is somehow that particular principle can be also a little bit precise. So we can see that China China has a really huge population growth, and now it leads to the highest number of annual CO2 emission per country. So it has, I think, 990 million tons of CO2 generated per year in 2017. This is followed by the United States with almost half of the China's CO2 emission, which is 5,630 million tons of CO2. So big countries like Russia also leads in this data. So next slide. So maybe you are wondering, is the oil and gas industry responsible to this greenhouse gas emission? Well, I have an answer for you to that. Okay. A part of that is yes, and a part of that is also no. Okay. Let me discuss to you first the yes part. Okay. The, the oil and gas industry is responsible for high greenhouse gas emissions by sector. Greenhouse gas emissions worldwide because the oil and gas industry is the major or the highest contributor for energy generation and consumption. But if we will look at this data very closely, we can see that among all of these things, of all of these sectors listed here, the road transport, which you can see on the right side, the right side of this graph, the road transport under the transportation sector, the road transport has the highest greenhouse gas emissions. In the Philippines, this data remain true. Okay, majority of our greenhouse gas emissions in the Philippines is accounted to the road transportation sector. So the road transportation leads by 11.9% of the greenhouse gas emission share per sector. And it is followed by, I think, by the residential buildings. Residential buildings are those who are requiring energy to be used in their daily lives. For example, for electricity, for cooking, etc. And I think it's also being followed by it's being followed by other industries and by unallocated fuel combustion, 7.8. But that one, in the unallocated fuel combustion, it doesn't pertain to the oil and gas industry. The oil and gas industry, which the upstream rather, the upstream oil and gas industry is the one that you can see on the left side of the allocated fuel combustion on the left side. So fugitive emissions from energy production, this includes flaring, so flaring and etc. Anything that is being emitted by the upstream sector. So that is only 5.8%. So meaning to say, the upstream, which is in charge in the exploration and the production of crude oil and natural gas, and also condensates, is not the major is not majorly major is not the primary responsible for the high carbon footprint worldwide. It is the consumers, which include the transportation sector, the road transportation sector rather, and the residential buildings, which includes all of us. So maybe there is a need to rethink about greenhouse gas emission, and not only making pinpointing to the upstream sector, because the upstream sector is only accountable for the 5.8% of the greenhouse gas emission. But later I will discuss to you why we should not settle on this. Okay, why we should decrease the 5.8%. Next slide. Sorry, my nose is a little bit itchy right now. So, so what is the impact of having a high carbon footprint? So we can see here throughout time that our global temperature is starting to rise, and it's not decreasing. It's not showing a level of decreasing. So it's still coming up to these dates. So we have a certain threshold of global temperature increase, or sorry, annual global temperature increase. And if we will reach that, many people, including many organisms, including human, animals, plants, will not survive in this temperature increase. I think I do not need to discuss this further, because I think we are all familiar about this. Next slide, please. Okay. So I was discussing about the impact of these emissions. So it could actually lead to many different problems that could have irreversible impacts, such as forest fires due to high temperatures in certain locales. It can also lead to drought. When there is drought, some animals may not survive, and some plants can also not survive. And this doesn't only limit to plants and animals. Also, humans cannot survive without enough supply of food and water. There's also we can also see a lot of pictures of the melting of the ice caps in the North Pole. So If this will continue, then our our sea level will also rise, and it can also lead to flooding, and also it could uh, submerge some localities. So um, global warming is also responsible for unpredictable and extreme weather conditions. I mentioned earlier that one of the extreme weather conditions could be drought, and could be high temperature rather, which can result into drought. And on the other hand, it can also lead to high evaporation rates of water bodies, especially the surface waters, and also water from the plants, from different organisms and other sources. So if there's a high evaporation rate, then there's a higher tendency there's a higher tendency that there will be more frequent rains with heavier rainfalls. So whenever there are heavier rainfalls, some localities can experience flooding, and flooding is not a good sign. It could lead to many diseases and deaths. With high CO2 concentration, with high CO2 emissions, it can also lead to a high CO2 concentration in the ocean, because CO2 or the CO2 can lead to can be dissolved and can settle in the ocean floor, and could increase the acidity of ocean, which can lead to the death of many organisms, including corals, which serve as habitat to many organisms like fish and other sea creatures. And it without this habitat, it could also lead to have with this habitat loss, it can also lead to biodiversity loss in that particular area. So, what is the danger on that? Source of food again. So, also the high increase in the temperature can also exacerbate the water quality in some places, in some surface waters like lakes, rivers. In the Philippines, we're also experiencing that phenomenon in some part of the country. So it could lead to many fish kills, etc. So next slide, please. So I keep on showing to you all of this because we wanted to know first um, the importance of not trying to increase or trying to help decreasing the CO2 emissions worldwide. Let me show to you the basic needs of human: food, water, shelter, clothing. So if 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 there's an or abnormal climate conditions worldwide, then it will lead to if it will lead to drought, or it will lead to flooding, it will affect the water and food supply. I remember that in this year and in the previous years in the Philippines, we've been experiencing a lot of problems in the agriculture because of frequent heavy rainfalls. Not just rainfall, but frequent heavy rainfalls lead to had led to the destruction of many agricultural lands, including including those areas that we highly depend food from. So as a result, we had a lower supply of food, um, which also led to the increase of the prices of the food in the country. So when there is drought, we could also it could also lead to a limited supply of water, and if there are heavy rainfalls, it could also affect the quality of water. Water may not be potable if there are heavy rainfalls. Maybe some of you will say that uh, heavy rainfalls are good because uh, more quantity of water. Well, that is actually true, but during heavy rainfalls, it could lead to higher turbidity, and it could also contaminate the water supply sources, uh, which may result in uh, which may compromise the quality of water. Okay. So in some places where there are also drought and heavy rainfalls, it can lead to habitat loss. So habitat uh, for animals and plants, animals rather. So it is also applicable to humans. So even when if the area has limited food source or has limited water sources or both, then people might opt to migrate somewhere else. So in if there are heavy rainfalls, it can also destroy their shelter. So clothing, which is also derived from some raw materials in the agriculture, if we have limited water supply or if we have drought, then we cannot produce the raw materials needed for to produce the clothing. So these are just basic needs. So next slide, please. Other than that, we have other basic needs. If we are problematic, for example, in our place here in Palawan, we have frequent brownouts. It would actually affect uh, our other needs, such as Wi-Fi. Okay? It could also affect our other needs like safety, or sometimes it can also affect our we cannot perform at work or school when there is no electricity. So next slide, please. But the the international sector are working hard on this. This includes also not only those that are involved in the United Nations, but there are in the academe and industry sector wherein we are pushing towards achieving sustainable development goals. This is to address or to minimize the problems being sorted from the problems that I or the issues that I've shown you earlier. So next slide, please. So how about the oil and gas industry? Do you think we are affected of these problems? We are just talking about carbon dioxide emission. I've mentioned to you earlier that the oil and gas industry is only accountable in 5.8% of carbon dioxide emission. Can we show the next slide? Next slide, please. Okay. So we know the answer in the previous problem that we are only accountable in a smaller proportion of the CO2 emission worldwide. However, there is the oil and gas industry remain challenged because of the oil and gas industry major catastrophe. I think these are all familiar to all of you. These major disasters, the Piper Alpha, the massive oil spill in the Gulf of Mexico, and this has resulted in irreversible environmental impacts. So this includes habitat loss, biodiversity loss, CO2 emissions, and many more. So it's been affecting not only animals and plants but also people. It has affected the food supply, the water supply, and many more, which are vital to the survival of many organisms, again, including human, plants, and animals. Next slide. Again, we will go back to this part. Um, we will go back to this part because we need to understand that although we are only accountable to 5.8%, and that the road transportation industry should be the one who need to work on decreasing their GHG emission, we still need to decrease the 5.8% because we do not want to contribute, or the the industry do not want to contribute in the worsening conditions of the world. Especially, there are many vulnerable populations worldwide are affected by these problems. So not only in the United States, or not only in the Asia Pacific region, but also in other parts of the world like Africa and some part of the mostly in Africa. So next slide. Mhm. So wait, I think this is not the. Can you go to the next slide? I don't think this is. We should be here. Next slide. Next slide, please. Okay, let's just go back to. Um, okay, so before we discuss what can we do and why there is a movement for renewable energy, let me remind you by going back to the previous slide. Can we go back to the other slide? Uh, okay, I think that's the one. Okay, so one of our greatest challenges is not only the environmental impacts of the oil and gas industry, but because of the major catastrophe in the oil and gas industry that I've shown to you earlier, it resulted in a lower social acceptance for fossil fuels worldwide. So many people see the impacts and are experiencing the impacts of those major disasters. So even if it happened only in a certain area, proportion of the world. But perception is reality. When people believe or when people believe and claim that a certain thing is true, then it could be that their own reality. If that is their reality or if that's their perception, then therefore, even if there is a demand, they will opt to not create a demand for fossil fuels because they believe that whenever you're using fossil fuels, you are also contributing to the environmental challenges worldwide. I'm not saying that it is incorrect, but it is both correct and incorrect. So perception is really powerful, but we have to do something about it. That is why, next slide. That is why we need to have some movements to, in order for us to contribute to the solutions to these environmental challenges. So I will discuss to you the history why there is there is a movement for renewable energy resources. I will take you back to the history. So let's call this session towards decarbonization. So previously, during the 1973, there was an oil embargo. So there was a current war between, I think, Israel and some part of the Middle East, which is Saudi Arabia and others. So when the United States tried to help the Israel, the Saudi Arabia declared an oil embargo to the United States, meaning to say that the Saudi Arabia um, will not export um, fossil fuels products to the United States, because back in time, um, the oil and gas sector in the United States is not yet that strong. Okay, it's not yet that established. So what happened is that they got lower because there is no high influx of or the normal influx of the exported exported hydrocarbons. Then their local supply began to being threatened. So it started to decrease with no sign of with high demands. It started to decrease, and to the point that the the local production could not is not sufficient to supply all the demand. So that is why there was a gas shortage in the United States back in 1973. So next slide, please. So The general public is being prepared to face energy crisis in the United States, and that is perceived to be the forthcoming. So, since the demand for oil is unlikely to decline, it is inevitably means that the price will increase probably quite dramatically. Earlier, we mentioned about population growth. Every year, we can see that in the United States, there are more migrants, and there are also more increase in the population because there are many babies that are being born yearly. Okay, so every day, not only yearly. So we can see that the demand, that is why it has been mentioned here that there is no sign that the demand will likely decline during those time. That is why they faced an energy crisis back then. The United States was trying to find ways on how to overcome that problem in terms of their energy crisis. Next slide. So this crisis attributed to the peak oil theory, and to remedy this, they need some measures in order to decrease dependence on energy, possibly decreasing per energy consumption. And second, they need to find alternatives to fossil fuels. Back then, they've been using some of the homes in the United States are already using some renewable energy resources such as the wind energy. So next slide. So now in 2011, there was a survey conducted by Ipsos, which aimed to know to determine the public's perception toward energy sources. So as you can see, right now, people are clinging towards more on renewable energy. So, and the most popular renewable energy resource is the solar energy, and nuclear energy is the least popular of all. Next slide. So, wait, I think I forgot to mention some parts in the previous slide. Can we go back and another one? Okay. So mentioned here that they are looking for as a remedy, they're looking for alternatives for fossil fuels. This is also the time when the government or the international agencies, I think it's the IPCC, they actually met with some global leaders, and they tried to discuss other alternatives to fossil fuels. And as a result of this discussion, this dialogue between global leaders, they come up to they come up to a conclusion that there is a need for renewable energy. So this is also the time in the United States during the embargo, during their energy crisis, they try to promote renewable energy through the IPCC. So right now, I think IPCC is attributed to the United Nations. They're not doing anything bad, but that is what happened back then in the first IPCC, I think. So I think that was on the first IPCC convention. So so they tried to promote the renewable energy, but that was also the time when they discovered a breakthrough technology in the oil and gas industry, which helped them boost their economy and also address their energy crisis. I will show it to you later. So next slide. Next slide, please. My nose is really itchy right now. So so let me show you the USA energy outlook. So in the previous years, we can see that the petroleum and other liquids, although the perception of the people are clinging towards more on the renewables, especially on the solar, we can see that the energy usage or energy consumption in the United States are is mostly on the use of petroleum and other liquids for energy generation. So it is leading until now, and it is also projected to lead in the nearest future at up to 2040 in the United States. However, among all of the energy resources shown here in this graph, we can see that the coal uh, is the uh, is declining and is projected to decline after 2018. Okay, but the greatest winner here is the renewables. The renewables after 2010, we can see that there is a gradual increase in the demand, and it is projected to also increase in the nearest future up to 2040. Next slide, please. Let me show to you also a graph showing the electricity generation for various energy sources from the Energy International Agency. We can see also some projections from 2018 up to 2050. We can see that natural gas will remain the most popular of all the choices or alternative for electricity generations in the United States, as an example, and renewable energies will start to emerge up to 2050 based on their projections. Nuclear will also start to decline in the nearest future, and coal as their alternative source for electricity generation will also start to decline up to 2050. So you can see on your right side that among all the renewable energy resources, it is projected that the solar PV or the solar photovoltaics will remain the most popular choice for renewable energy resource in the United States, to be followed by wind and geothermal. To be followed by wind and then hydroelectric, and then others and geothermal. So, but these are just only projections by the Energy International Agency. But as you can see here in this data, it can also somehow consistent to the to the perception of the people who are being served, who were surveyed in a previous study, the one that I've showed to you earlier. Next slide. So earlier in the previous slide, I've shown you the projection for electricity generation. Here, I will show you the different energy consumption by sector. Electricity power, electric power rather, or for the use of energy for electricity will remain the highest up to 2050, and it is also projected that the industrial energy consumption will start to increase starting 2019 up to 2050. But in the transportation sector, I think it will start to decrease starting 2019. Maybe this is because I think they are planning to put more mass transportation as their modality for going to one place to another. That is why I think the transportation sector will start to decline. Okay. So based on the other projection of the Energy International Agency, you can also see here that the fossil fuels, which include petroleum and other liquids and natural gas, will remain the most popular for the energy consumption by fuel. However, we can see that the renewable energy resources other than the hydro thermal will emerge starting 2019. And we've seen already the projected source of the renewable energy. So next slide. Next slide, please. Next slide. Hello. Okay. So so towards decarbonization, the energy outlook for 2040 as compared to 2060 under various scenarios, such as renewables, includes wind, solar, geothermal, biomass, and biofuels, are shown in this is shown in this slide. Okay, next slide. So I'll just explain it to you briefly or what this graph, how can we interpret this graph? So starting after 2016, they actually projected up to 2040 what will be the energy mix of the United States. So they projected here that they projected different scenarios and different energy mix, which includes renewable, hydro, nuclear, coal, gas, and oil. We can see that oil will remain the most popular here. So to explain to you the meaning of those scenarios, EP stands for evolving transition. It is shown to be the direct function of public perception that dictates government policies, technology, and social preferences. ICE is internal combustion engines. We can see that if we started banning the international combustion engines, the fossil fuels, which are in green and red, will still remain the most popular up to 2040. And renewables will just start to increase, but only a little. Um, if we will try to push for using less gas, we can still see that there's a slight decrease in using of the natural gas, but the increase in the usage of renewable energy resources will not be that significant, or it will still be low. Okay, so if we will try to push the renewable energy, it means that we will try to incorporate more renewable energy to different technologies and different processes, including commercial and industrial processes. Um, there will be an increase in the use of the renewable energy resources, but again, the use of fossil fuels will remain the most popular. Can we show the next slide? Okay, next slide. Uh, so I think I'll just make a shortcut discussion for this. FT stands for full transition to renewable energy, and EFT stands for extra full transition. Okay, so if we will try to put a full transition to renewable energy, it will still not result into the decrease of. It will result a little decrease in the use of fossil fuels, but not all. Uh, it will remain in the energy mix. And for extra full transition, we will still use a lot of oil and gas in the future. Next slide. So next slide. Next slide. Next slide. Okay. So we can see here the reserve to production ratios of the oil and gas industries in 2016. We can see that we are still performing. The oil and gas industry is still performing. Many of you might be thinking that because of several publications being published or some news that the oil and gas industry will not exist after 2030, maybe that data is somehow incorrect because based on the projections, we will still have high demands and also high production in the nearest future. So, but we cannot deny that the global hydrocarbon resources are declining. It is declining. So, next slide. So, I think I'll just skip on that. I think I've already mentioned it with you. Next slide. So, ever since the oil price decline in 2014 from historic high oil price, the world oil market has become vulnerable to uncertainty and economic gloom. It's difficult to separate this oil price issue from the perception, like what I mentioned earlier, perception is reality of environmental concerns. Even more difficult is to decipher the role of this perception on energy pricing of both renewable and non-renewable resources. So next slide, please. So I'll just summarize this thing. So the oil price is not only affected by the supply and demand. So that is the common knowledge that we have, that every price of any commodity is affected by supply and demand. But in the case of energy industry, particularly the crude oil and natural gas, the prices of these commodities are affected not only by the supply and demand, but also by the politics, the energy politics. So you can see in this particular image or graph, you can see that the different major events that happened worldwide could affect the prices of oil. For example, I mentioned the oil embargo in the United States. You can see it in the number two on the graph, the Arab oil embargo. It led to the increase of the oil price in the United States. So it decreased dramatically to the point that some people could not afford fuel anymore. So there are also other major crises that are presented here that could also that led to the increase and decrease of the oil price throughout time. Next slide. So next slide. I think I'll just skip on this. It's the same thing there. So what else can we do in the oil and gas industry? I think I can finish this in 2 minutes or 3 minutes. So what else can we do in the oil and gas industry? We need to do, although we know that we are only accountable to, again, to the 5.8% of the CO2 emission, we still need to decrease that number in order to contribute to the solutions of the worsening conditions worldwide. Especially, there are people who are living in vulnerable places. So let me show to you our publication in Elsevier. We conducted a review on sustainable oil and gas production research using a bibliometric analysis. I've written this last year with my students, and it's being cited by different authors worldwide already. And next slide, please. Um, Next slide. Since we are in the academe and we are in the sciences, engineering, and industry, we need to do something about it. We can see here the annual publication growth of papers that are related to sustainable oil and gas production. So we can see that the numbers are fluctuating. It means that the petroleum engineering sector, particularly in the academe, should publish more, should conduct more research on how to make our industry more sustainable, and how can we contribute to the improvement of our industry, particularly related to the environmental challenges. Next slide. Okay. And I can say by just showing this graph, I can say that if you want to be cited, there's a high chance that if you publish papers that are related to sustainable oil and gas production, there's a high chance that your papers will be published. Based on this data, those are related in this particular field are also has influence to other researchers. That's why they cited your work. So next slide. And I think this is the last slide. There are still a lot of opportunities wherein we can explore to improve the sustainability of the oil and gas. This includes improving CO2 emissions in our sector. And as members in the academic sector, we can do something about it. We can influence other people, including the industry, to become more sustainable through sustainable development approaches. This is to address the worsening condition related to CO2 emissions. And next slide. Thank you so much for listening. I hope that you learned something from my discussion, and I hope that you were able to understand some of the answers to the problems presented on the second slide of this presentation. You may contact me in this email address. I think this is incorrect. I think it's only J Ignacio at psupalawan.edu.ph. Thank you so much and have a wonderful day.
Wow, that was amazing, Engineer Ignacio. We will move on to our next activity. Let's now open a Q&A session because I'm sure all of the participants can't wait to ask questions. And for those who have questions, you may use the raise hand feature or feel free to drop the questions in the Zoom chat box. Yes, they're shy to ask questions, sir, but there's someone who has sent me a message. Her question was, what's the most easiest way or most efficient way of solving the pressing social environmental challenges in our industry, the oil and gas industry? Again, what's the most efficient or easiest way of solving the pressing social environmental challenges caused or encountered by the oil and gas industry?
Uh, Let me tell you with my honest opinion. There's no easy solution to any problem, especially if we're dealing with a problem that could affect a lot of people, not only in that particular locality. So, if we're talking about a solution for this, if it is easy, then there will be no problem with CO2 or GHG emission worldwide. But I think I think what I can only suggest is that whenever there is in a certain company, for example, before you before you decide on applying a certain process or a certain technology, um, there are a lot of decision makers involved. So that doesn't only require one person to decide. So before the decision makers decide what technology or process to be used in a certain operation in the oil and gas industry, for example, they need to conduct a study first or a survey that involve the people that could be affected by their decisions. For example, those who are living in the nearby community, those who are also not really living in the nearby community, but could be indirectly affected by those problems. So they need to conduct a study first and check on the opinions of the people so that their approach will be more holistic. But if it pertains to a certain event that is already happening, for example, um, there's already carbon dioxide emission because the operation of the industry has already started in a certain place. Then the only way to solve it is just to, if the complaint is about the carbon dioxide emission, is that they need to find ways um, on how to control those carbon dioxide emission. There are some certain technologies which we call the net zero emission technologies, in which they apply different approaches such as carbon sequestration, carbon offsetting, etc., in order to control the release of carbon dioxide, which could affect the communities not only nearby, but it could also affect communities wherever they are located. So the industry must think forward on um, performing those tasks before coming up with a certain solution or process for their operation. But again, there's no easiest solution for any industrial operation. I think if we will just talk about the easiest solution, I think it will just be uh, come up with facts first, with data facts before deciding. Try to evaluate and weigh those data before coming up with a certain decision for the benefit of your company and also for the people. I think that part is quite easy and difficult at the same time. I hope I was able to answer your question.
Thank you very much for that, sir. I believe there was another question. Thank you. There are two. Try to send it here in the chat box or raise your hand. So, as per stated, you said earlier that oil and gas industry actually is not the biggest contributor for global greenhouse gas emissions. Then why is it that every time there is a problem regarding the atmosphere, the industry is the first one to be blamed?
Okay, because mainly because we are the one who's producing the oil and gas. That is the main problem. We are the source. If there's no upstream sector, then there will be no oil and gas, and it's easier to present to the people the pictures of flaring, and it's easier to scare them, uh, so that they can present that the oil and gas sector is the one that could is the one that is mainly responsible for greenhouse gas emission, because we can see the smoke from the flare, right? We can see a lot of smoke from that. But if we will take a picture of cars emitting smoke after combusting, while they're running after combusting their engines, right? So it is not as impactful. So in environmental management or environmental engineering, we have this what we call severity versus what do you call that? Severity versus uh, frequency, or what? I forgot the right term. Um, so even if they are producing micro smokes, for example, but if there are a lot of cars, which we know that there are a lot of cars in every city, in every municipality, or in any part of this world, the combined impacts of those emissions results to a major effect to the environment. So we just don't see it per individual car. Okay. So, but if they will just look at the rig and they just see one rig having flaring, and then they can see smoke, it's easier to present to the people. So I think that's the answer to that question.
Okay, sir. I believe there's also a question from one of our delegates from
Again,
PSP.
I mentioned earlier, perception is reality. When
Okay.
you were able to control the perception of the people, then it will be the reality to many, or for them. So if they believe that if they are convinced that um, the oil and gas industry is is that really emits smoke, then they will believe that they are the major contributor for carbon dioxide emission. But nobody is questioning the solar photovoltaic cells. So nobody's questioning solar PVs. But if you conduct, there are a lot of studies. If you browse the different publications, the life cycle assessment or life cycle analysis for some renewable energy technologies such as solar PVs, they are not really that environmental friendly. It is they have high environmental impacts. You just don't see it because they do not emit impact while they're operating to produce electricity. But before you produce those solar photovoltaic, that is where the impacts came from. Will come from. So from mining, from manufacturing, etc., and until the end of life part of the photovoltaic cells, the environmental impact is not really that good. It's not performing well. I think I can see some questions. Should I read it? Should I read the questions?
Actually, the first one comes from a delegate. So he will be joining the case
Can you
competition.
speak more louder?
Oh,
Because I
sorry.
can't really hear it.
Okay. A question from one of our delegates, sir. In your opinion, is it possible for the oil and gas industry to be a carbon negative industry? A good point of view would be utilizing the carbon dioxide enhanced oil recovery.
Okay. Um, Net zero or carbon negative is actually a concept. It is actually a principle. But it doesn't really mean that if you are, it doesn't really mean that that you're using a net zero technology or carbon zero technology, just like what you're saying. It doesn't really mean that you are not emitting carbon dioxide. It's just you divert the direction or the flow of the carbon dioxide in the environment. You put it somewhere else. But the good thing there is that when you put it somewhere else, some of the organisms, or yeah, some of the organisms you can find in the environment, in the natural environment, they are natural consumers of carbon dioxide. So there won't be a problem to that at all. For example, plants. So if you try to divert the some carbon dioxide, I'm not saying all, but some carbon dioxide by planting a lot of trees in a certain place, etc., and then diverting the carbon dioxide there, then uh, the trees will consume the carbon dioxide through photosynthesis, and then as a result of that process, they can actually produce food, and they can also produce oxygen, clean oxygen for the people and animals to breathe. So, was I able to answer your question? Hello, hello. Okay, okay. I think there's another question. I'll just read it. Is it really possible to have energy transition? We are already doing that. We are doing certain transition, but again, I've shown you full transition and extra full transition, but transition is not really that feasible as of the moment. We are still not yet there. We still require more R&D to get there. Even the oil and gas industry, we are still trying to improve. We are still trying to be more efficient. We are still uh, trying hard to improve our operations. So we are still not on the point that we have already maximized all the technologies used for used for producing energy. So, but as per your question, for the energy transition, we're already there. That is why the energy mix share for the renewable energy is starting to increase because of that energy transition. But transition doesn't mean abrupt transmission or immediate transition, rather immediate transition. It will definitely require us a lot of time to for the transition of from fossil fuels to full renewable energy. But that is where we can draw a line because we still do not know how the full transition to renewable energy will work. Uh, was I able to answer to the question? Hello, can you still hear me? Hello.
Sir, you are audible po. I believe he has responded. I believe you have answered the question well. Okay, I guess that sums up for our Q&A session. Thank you so much, Engineer Ignacio. Thank you to all the participants who have asked questions to Engineer Ignacio. And also thank you, Engineer Ignacio, for answering all their inquiries. But due to time limitations, I believe that sums it up. Again, we're very much thankful and very grateful for your valuable insights and experience. And also thank you for all the participants for your time and enthusiasm. Well, on behalf of the Speak Up 2023 committee, I would like to say a big thank you again to Engineer Ignacio, who has taken the time and energy to share his knowledge with us this morning. We look forward to the opportunity of working with you again in the future. For the committee, you may share your screen. So, as a form of appreciation, allow me to read the certificate. Certificate of Appreciation is honorably presented to Engineer Jonathan Jared J. Ignacio for imparting his valuable insights and experience in Speak Up, the perspective of the oil and gas industry towards energy transition. Once again, thank you very much, Mr. Ignacio. Maybe there are a few words you want to convey to all of us.
Um, for all the students, can you hear me? Uh, can you still hear me? Okay. For all the students, I hope that you venture in research in trying to improve the sustainable development in the oil and gas industry. We are the hopes of this world. So I know that most of us, or all of us rather, wanted to be a part of this very lucrative industry. But we need to do something to help the people that are surrounding us, and also the people that are not surrounding us but could be affected by the increasing challenges in terms of environment worldwide. So please try to venture on sustainable development research for your undergraduate thesis up to your graduate thesis.
Sounds great. Thank you again, sir. And again, maybe the participants now can turn on their cameras for a while, for we will hold the virtual photo session with our dear speaker for this first session. For the documentation department, you may now take over for the photo session. I would like to request everyone to please open your cameras. And for the committee, who shall take the screenshot for our photo session? Okay, is everyone ready? Documentation department, are you ready as well? Okay. Documentation department, you may now take over.
Okay, I'll be taking the photo in 3, 2, 1. Okay. Since those who are on camera only one slide, that'll be all. Thank you.
Okay, thank you so much, documentation department. And I guess that's a wrap up for this first session. Once again, I would like to express my gratitude to Engineer Ignacio. And again, thank you for all the participants for paying close attention to this session. Again, I am Nicole Zainadiao, and as a moderator, I'm very much thankful for your attention and participation. For Engineer Ignacio, you may now leave the Zoom if you have other important business. And for the next session, I leave it to, I believe, Anaya or Craig. Yeah, I leave it to the next MC. Thank you.